Okay, we're going to be doing operations with functions. So we have two functions, a quadratic and a linear, f of x and g of x, and we're going to try to find f of x plus g of x. In order to do f of x plus g of x, you take the f of x function, x squared plus 2x minus 3, and you're adding it with the g of x function, x plus 1. And combine your like terms. X squared, there's no other like terms. Well, 2x plus positive 1x becomes 3x. Negative 3, positive 1 becomes negative 2. So f plus g of x is equal to x squared plus 3x minus 2. Understand that this notation and this notation mean the same thing. Okay, I gave you two different ways to write it. So now we're going to do f of x minus g of x. The one thing you got to pay attention to here is pretty much the same thing, x squared plus 2x minus 3. But if I just do minus x plus 1, that's going to be wrong. What I need to do is I'm subtracting that whole function of g of x, so I got to put parentheses around it. And now I'm going to leave this part the same, but I need to distribute that negative 1, so that's going to be negative x minus 1. So I have f minus g of x is equal to x squared, then positive 2x, negative x becomes x, negative 3, negative 1 becomes negative 4. So we have f of x times g of x, which means we're going to take the f of x function, x squared plus 2x minus 3, and multiply that with the g of x function, x plus 1. When you multiply it, you have to distribute everything into the other parentheses. So first I'm going to distribute the x squared, that becomes x cubed, plus x squared. Then I'm going to distribute the 2x times x is 2x squared, 2x times 1 is 2x, and then distribute the negative 3, so that becomes negative 3x minus 3. Combine your like terms. I have x squared plus 2x squared. Okay, well, nothing combines with x cubed first. Then x squared plus 2x squared becomes 3x squared. 2x negative 3x becomes negative 1x, or negative x minus 3. So that means f times g of x is equal to x cubed plus 3x squared minus x minus 3. Alright, so we have f of x divided by g of x here. So I have x squared plus 2x minus 3 over x plus 1. There's nothing really I can do to simplify this. But I do need to remember, look for your restrictions, and the denominator cannot equal 0, so that means that x cannot equal 1. I'm sorry, x cannot equal negative 1. We're going to go over the domain and range of a lot of these later in class, but now we're going to move on to composition functions, or composite functions. Composite functions is when you're plugging one function into another one, and there's two ways to write it, or there's two notations for it. One is like this, f of g, that's the way you say this, but this can also be written like this, okay, f of g of x. Or you could have g of f, which can also be written g of f of x. And in this one, you're plugging the g function into the f function. In this one, you're plugging the f function into the g function. So if I have f of x equals x squared plus 1 and g of x equals x minus 3, if I'm looking for f of g of x, okay, it can also be written like that, f of g of x, then I'm going to plug the g into the f, okay, which means I'm going to take the f of x function, x squared plus 1. Instead of that x, though, I'm going to plug in the g of x function. Alright, well, what g of x is equal to is x minus 3. So I'm going to have x minus 3, which is g of x, squared plus 1. When I square a binomial, I need to write it out twice and distribute. So that's going to be x squared. This becomes negative 3x, that's going to be negative 6x minus 9 plus 1. I'm sorry, it should be plus 9. Negative 3 times negative 3 becomes plus 9. Then combine your like terms, and I have f of g of x is equal to x squared minus 6x plus 10. So here's the different one. I have two different f of x functions and g of x function, but the question is different. Instead of f of g of x, in this one I'm finding f of g of 1, which means I could do this two different ways. I could first find g of 1. Well, to find g of 1, I'm going to plug 1 into the g function. So I get 5 minus 1 squared. So that's going to be 5 minus 1. You're not squaring the negative 1, you're squaring the x, and the x here is positive 1. The minus comes after you square it. Okay, so 5 minus 1 is 4. Now what do I do with that? Well, g of 1 is equal to 4. So that means that f of g of 1 would be the same as f of 4. So now I can plug 4 into the f function. 4 squared minus 7, 16 minus 7 is equal to 9. So f of g of 1 is equal to 9. For this second problem, f of g of negative 2, I'm going to do it a different way. Okay, I'm going to first find f of g of x. Okay, so I'm plugging g into the f function. So I have 5 minus, I'll show it this way. The f function is x squared minus 7. So instead of this x, I'm going to replace it with g. And that g function is 5 minus x squared. So I'm going to square that. 5 minus x squared times 5 minus x squared minus 7. So that becomes positive 25. This is going to be negative 5x squared becomes negative 10x squared, and negative times the negative becomes positive x to the fourth minus 7. So I'm going to put it in standard form, x to the fourth minus 10x squared and negative 7, positive 25 combined to be positive 18. Okay, I've moved it over a little bit to give me some more room. Well, now that's what f of g of x is. X to the fourth minus 10x squared plus 18. And I could now to find f of g of negative 2, I could plug negative 2 in. Negative 2 raised to the fourth minus 10 times negative 2 squared plus 18. Negative 2 raised to the fourth, because it's even, it's going to be a positive 16 minus 10. Negative 2 squared is 4 plus 18. So I have 16 minus 40 plus 18, and that's going to equal negative 6. So f of g of negative 2 is equal to negative, and that's negative 6, so f of g of negative 2 is negative 6. You could have done that the same way I did the first one. They both end up being correct. Okay, I'm going to use these functions for the U-try problems. Go ahead and try to find f of x times g of x. F minus g of x and f divided by g of x. And then g of f of x, f of g of 2, and g of f of negative 3.